As far as rules to draw ray diagrams for convex mirror, we have totally 4 rules. I will be explaining all the 4 rules one after another. First of all, let's start with rule number 1. Take a convex mirror. This is the reflecting surface. Let's draw principal axis. This is pole. Principal axis. Focus will be on the other side of the mirror. Behind the mirror, you will get focus. Got it? And center of curvature. The first rule is the ray parallel to the principal axis will reflect such a way that it appears to be moving away from the focus. Okay? It appears, after reflection, it appears as if it is coming from focus. This is rule number 1. If you extend the ray backwards, the line will join the focus. The line will join the focus. Got it? Let us write the rule. A ray parallel to the principal axis appears to be coming from the focus after reflection. Okay? So this is the rule number 1. Parallel ray will reflect such a way that it appears that the ray is moving away from the focus. Got it? This is rule number 1 for convex mirror. Let's go to the rule number 2. Draw a convex mirror. Draw the reflecting surface. Draw principal axis. Note down pole, focus, center of curvature. The second rule says that any light ray moving towards center of curvature will be reflected back in the same direction. Any light ray moving towards center of curvature will reflect back in the same direction. This is incident ray and this is reflected ray. It will reflect back in same direction. Let's write down the rule. A ray moving towards center of curvature will reflect back in the same path. This is your rule number 2. Noted? This was rule number 1. Parallel ray will appear as if after reflection it appears as if it is moving away from the focus. Next, the ray passing towards center of curvature will reflect back in the same direction. Third rule. Draw a concave mirror as usually. Again, draw one concave mirror. Sorry, convex mirror. Convex mirror. This is the principal axis. Pole is here, pole. Focus, center of curvature. Rule number 3 says that if a ray is passing towards the focus, if a ray is passing towards the focus, this ray is passing towards the focus, after reflection it will become parallel to the principal axis. A ray moving towards focus will become parallel after reflection in case of convex mirror. Let's write the rule. A ray moving towards the focus becomes parallel to the principal axis after reflection. Is that okay? So a ray moving towards the focus will become parallel to the principal axis after reflection. The last rule, fourth rule. Take a convex mirror. Draw the principal axis. Note down pole, focus, center of curvature. The third rule says that a ray incident on the pole, will reflect back, making same angle with the principal axis. If the incident ray is making an angle theta with the principal axis, reflected ray will also make same angle with the principal axis. जो एंगल पे आया रे वो एंगल पे रिफ्लेक्ट होगा. समझ में आ रहा? अगर पोल के ऊपर रे इंसिडेंट हुआ जो एंगल पे इंसिडेंट हुआ वो रे प्रिंसिपल एक्सिस से जो एंगल बना रहा था वही एंगल से वो रे रिफ्लेक्ट हो जाएगा. That ray will reflect with same angle. Got it?
Yes, sir.
Let's write this last rule. A ray which is incident at the pole will reflect back making same angle with principal axis. These are the 4 rules. Now let's draw the rules to draw ray diagrams of concave mirror and convex mirror. दोनों का रूल्स एक साथ ड्रॉ करेंगे ताकि आपको दोनों में क्या डिफरेंस है आपको मालूम होता. दोनों में भी 4 रूल्स है. इमेज कहाँ फॉर्म हो रहा मालूम करने के वास्ते रूल्स बहुत ज़्यादा इंपॉर्टेंट है. ओके, सो लेट अस चेक द रूल्स साइमल्टेनियसली. यहाँ पर कॉनकेव मिरर का रूल, यहाँ पर कॉन्वेक्स मिरर का रूल, दोनों एक साथ ड्रॉ करके डिस्कस करेंगे ताकि आपको कुछ कंफ्यूजन है वो निकल जाता. ध्यान से देखिए. फर्स्ट रूल नंबर 1 को ड्रॉ करेंगे. रूल 1. ओके, दिस इज ए कॉनकेव मिरर. Principal axis, pole, focus, center of curvature. I am drawing convex mirror over here. This is the convex mirror. Let's draw principal axis. Pole, focus, center of curvature. दोनों में बेसिक डिफरेंस आपको मालूम हो रहा कि हियर कॉनकेव में फोकस सेंटर ऑफ कर्वेचर इन फ्रंट ऑफ द मिरर रहता. कॉन्वेक्स में फोकस सेंटर ऑफ कर्वेचर बिहाइंड द मिरर रहता. यह है बेसिक डिफरेंस. A ray parallel to the principal axis. Here also a ray parallel to the principal axis. In case of concave mirror, after reflection, the ray passes through the focus. In case of convex mirror, it will reflect in such a way that it appears to be coming from focus. This is the difference between convex and concave mirror as far as rule 1 is concerned. Any doubt in this? Okay, then rule 1 is done. Let's go to the rule 2. This side concave mirror and here convex mirror. First of all, let us quickly draw the mirrors. Concave mirror, principal axis, pole, focus, center of curvature, convex mirror, principal axis, focus, center of curvature. Now, second rule says that a ray passing through center of curvature, a ray passing through center of curvature will reflect back in the same path. Here, a ray passing towards center of curvature, a ray passing towards center of curvature will reflect back in the same direction, same path. This is the second rule. This is the basic difference between concave and convex mirror. Any doubt in this?
No, sir.
So ऐसा ड्रॉ करना है, कॉनकेव का रूल, कॉन्वेक्स का रूल. सेंटर ऑफ कर्वेचर से रे पास हुआ तो वो सेम पाथ में रिफ्लेक्ट हो जाता. रूल नंबर 3 ध्यान से देखिए. यहां पर कॉनकेव, यहां पर कॉन्वेक्स. Let's draw the figure of concave mirror, convex mirror. Principal axis, pole focus center of curvature, pole focus center of curvature. Now, any ray passing through the focus, if the light ray is passing through the focus and falling on concave mirror, after reflection, it will become parallel to the principal axis. Any ray moving towards the focus of convex mirror, after reflection, it will become parallel to the principal axis. That's it. Hope you understood this. Hope you understood this. Third rule. Okay.
Yes,
If a ray is passing through the focus, it will become parallel to principal axis. Now, last and final rule. Rule number 4. Let's take concave and convex mirror. This is a concave mirror. This is a convex mirror. principal axis. Okay, then the last rule says that if the ray is incident at the pole, making certain angle with the principal axis, it will reflect making same angle with the principal axis. It will reflect making same angle with the principal axis. If a ray is incident on the pole of a convex mirror, ray means light ray. If the light ray is incident on the pole of a convex mirror, making an angle theta with the principal axis, it will reflect back with the same angle, making same angle with the principal axis. Got it?
Yes.
Understood? Now here I want to tell one important thing. If the ray is passing along the principal axis and falling on the pole, then it has to go back in the same, making same angle with the principal axis. That means zero angle with the principal axis. So it will return back along the principal axis. If it is falling along the principal axis, it will return along the principal axis. Why? Because the angle made is zero. It has to maintain the same angle. Got it?
Yes.
So these are the 4 rules pertaining to convex and concave mirror. Parallel ray passes through the focus. Parallel ray reflects in such a way that it is coming from focus. A ray passing through center of curvature will reflect back in same direction. A ray moving towards center of curvature will reflect back in the same path. A ray passing through the focus will become parallel after reflection. A ray moving towards focus will become parallel to the principal axis after reflection. A ray incident on the pole will make same angle, reflect in such making same angle with the principal axis. A ray incident on the pole reflect making same angle with the principal axis. Now let us know how to draw a ray diagram in case of convex mirror to obtain the image. So see here, case 1 is object placed anywhere between pole and infinity. So wherever maybe the object is placed, you will get one type of image. Unlike in case of concave mirror, as you change the position of the object, you notice that we were getting different types of images. Some are virtual erect, some are real inverted, some are diminished, some are enlarged. But in case of convex mirror, wherever may be the object, you will get one type of image. मैं हिंदी में बता रहा हूँ, ध्यान से देखिए. कॉनकेव मिरर में जैसा ऑब्जेक्ट का पोजीशन चेंज करे, इमेज का पोजीशन चेंज हो रहा था, इमेज का साइज चेंज हो रहा था. कॉन्वेक्स मिरर में आप चाहे किधर भी रखिए ऑब्जेक्ट, एक ही टाइप का इमेज मिलता, आपको एक ही रे डायग्राम ड्रॉ करना पड़ता कॉन्वेक्स मिरर पे। तो यहाँ पर एक कॉन्वेक्स मिरर मैं ड्रॉ कर रहा हूँ। ये है एक कॉन्वेक्स मिरर, reflecting surface denoted by these small lines. Principal axis है जो is a imaginary line passing to the pole and center of curvature. You know that focus and center of curvature are behind the mirror. चलिए, ऑब्जेक्ट आप पोल और इंफिनिटी के बीच कहीं भी रखिए ऑब्जेक्ट। समझो कि ऑब्जेक्ट यहाँ है। लेट्स इमेजिन दैट ऑब्जेक्ट इज हियर, दिस इज द ऑब्जेक्ट ए बी। फर्स्ट रूल सेज दैट a ray parallel to principal axis will reflect in such a way that it appears to be coming from focus. It appears to be coming from focus. I applied the first rule. Next rule, a ray passing towards center of curvature. A ray passing towards center of curvature will move back in same direction. Here I am using solid line and dotted lines behind the mirror. I will be giving you dotted lines. The ray is incident and reflected in the same direction. Here both the rays are meeting at this particular point. यहाँ पर दोनों रेस मिल रहे हैं, यहाँ पर इमेज फॉर्म हो रहा, और इमेज डिमिनिश्ड है, वर्चुअल है, एरेक्ट है। इमेज कैसा है? डिमिनिश्ड, वर्चुअल, एरेक्ट। आप ए डैश बी डैश इमेज को देख सकते हैं। यहां पर अपन लिखेंगे पोजीशन ऑफ इमेज बिहाइंड द मिरर, size of the image diminished, nature of image. What is the nature of image? Virtual and erect. वर्चुअल एरेक्ट इमेज मिलेगा आपको, चाहे आप ऑब्जेक्ट कहीं भी रखो, पोल और इंफिनिटी के बीच में कहीं भी ऑब्जेक्ट रखो, एक ही इमेज आएगा, डिमिनिश्ड, वर्चुअल एरेक्ट। लास्ट क्लास में मैं समझा है कि ये डिमिनिश्ड और एरेक्ट इमेज के वजह से कॉन्वेक्स मिरर एक रेयर व्यू मिरर जैसा काम करता। ओके, इट इज यूज्ड एज ए रेयर व्यू मिरर। इज दैट ओके? So let us again draw ray diagrams to obtain the images in case of concave mirror for different positions. Okay, so in first case I will be putting the object between pole and focus. So let us draw one concave mirror. Principal axis, pole, focus, सेंटर ऑफ कर्वेचर। आपको अगर रे डायग्राम परफेक्ट आना तो ये डिस्टेंसेस सेम रहना, फोकस मिडिल में रहना, मिड पॉइंट ऑफ सीपी, इन दोनों का मिड पॉइंट एफ रहना। ओके, तभी आपको परफेक्ट रे डायग्राम मिल सकता। ये पोजीशन, दिस पोजीशन इज ऑल्सो कॉल्ड एज object placed very near to the object placed very near to the mirror. So object is placed between focus and pole. This is the first case. Let us find where the image is formed. Let us find the nature, size, position of the image. So अब ऑब्जेक्ट ड्रॉ करें, ऑब्जेक्ट ए बी है, मैं अभी नहीं लिखता हूं, बाद में लिखूंगा। ए बी ऑब्जेक्ट है, सो इसका इमेज कहाँ आ रहा अपन मालूम करेंगे। पैरेलल रे, फर्स्ट रूल कह रहा है कि पैरेलल रे, रे पैरेलल टू प्रिंसिपल एक्सिस। ध्यान से देखिए, रे ऑब्जेक्ट के ऊपर गिर के मिरर पे आना जब भी इमेज दिखता आपको। सो रे पैरेलल टू प्रिंसिपल एक्सिस विल पास थ्रू द फोकस। फर्स्ट रूल हो गया। A ray passing through the center of curvature will move back in same direction. यहां पर दोनों रेस आप नोटिस करें तो दोनों रेस डाइवर्जिंग रेस है। इन दोनों रेस जितना दूर ड्रॉ करे उतना दूरी दोनों के बीच में बढ़ता रहता। इमेज कहाँ फॉर्म होता, जब दो रेस मिलेंगे ना वहां इमेज फॉर्म होता। अब ये तो डाइवर्जिंग रेस है, इस तरफ तो रेस नहीं मिल रहे, तो अब रेस मिल सकते बिहाइंड द मिरर। जब ये रेस अगर पीछे की तरफ आप एक्सटेंड करें तो दोनों रेस एक जगह मिलेंगे, वहां इमेज फॉर्म हो रहा। वो इमेज वर्चुअल एरेक्ट इमेज है। वर्चुअल इमेजेस को डॉटेड लाइन से डिनोट करते। अभी ए बी अगर ऑब्जेक्ट रहा, इमेज क्या रहेगा, ए डैश बी डैश। सो अभी बोलिए आप नेचर ऑफ इमेज क्या है।
Virtual and erect.
वर्चुअल एंड एरेक्ट। साइज ऑफ द इमेज क्या है,
Large.
पोजीशन क्या है, बिहाइंड द मिरर। ये है फर्स्ट केस, इमेज इज बिहाइंड द मिरर। एनलार्ज इमेज को मैग्निफाइड इमेज भी बोल सकते हैं। सो ये पोजीशन में डेंटिस्ट यूज करता कॉनकेव मिरर को। डेंटिस्ट विल यूज दिस पोजीशन, he will keep the object very near to the mirror, that is when tooth is kept very near to the mirror he will get enlarged erect image. So tooth का enlarged image में उन cavities को clearly देख के टूथ को ऑपरेट कर सकते हैं। और शेविंग मिरर, जो भी मेकअप मिरर, शेविंग मिरर भी यही पोजीशन यूज करते हैं, क्योंकि जब मिरर बहुत करीब है फेस का तो आपको एनलार्ज इमेज मिलेगा और आप फेस का हेयर को अच्छा देख सकते हैं, शेविंग स्मूथली कर सकते हैं। सो ये है पोजीशन जहां पर शेविंग मिरर, इट इज यूज्ड एज शेविंग मिरर एंड डेंटिस्ट कैन आल्सो यूज कॉनकेव मिरर टू सी टूथ। गॉट इट? सो ये है फर्स्ट केस। सेकेंड केस को जाएंगे, केस टू। क्या है केस टू? ऑब्जेक्ट इज प्लेस्ड एट फोकस। Object is placed at focus. Let us quickly draw. This is concave mirror. Principal axis. Pole. Focus. Center of curvature. Object is placed at focus. First rule, I am applying the first rule. Any ray parallel to principal axis passes through the focus. A ray passing through center of curvature will move back in the same direction. Same path. It will move back in the same path. I am getting a parallel rays. यहाँ पर दोनों rays parallel है. It is assumed that parallel rays meet at infinity. Parallel rays meet at infinity. एक assumption है parallel rays will meet at infinity. क्योंकि सन रेसेस पैरेलल है, मगर इन्फिनाइट डिस्टेंस ट्रैवल करने के बाद अपन पूरे रेस सन से ओरिजिनेट हो रहे हैं, तो पैरेलल रेस कहीं ना कहीं एक जगह मिलना है, वो इन्फिनिटी का नहीं मिलते. जैसा सन रेसेस पैरेलल है मगर वो सन के पास मिल रहे हैं. तो ये है पोजीशन. यहाँ पर आप बोल सकते कि नेचर ऑफ द इमेज रियल एंड इन्वर्टेड बोल सकते हैं आप. साइज हाईली एनलार्ज्ड, क्योंकि जितना इंफिनिटी का नहीं मिल रहे बोले तो साइज बहुत ज़्यादा बड़ा हो जा रहा है, इस वास्ते हाईली एनलार्ज्ड इमेज बोल के कहा गया है. और पोजीशन एट इंफिनिटी, if the object is placed at focus we will get the image at infinity. ये पोजीशन आपको टॉर्च लाइट्स में या व्हीकल्स का हेडलैम्प्स में देख सकते हैं आप, जहाँ पर पीछे एक रिफ्लेक्टिंग सरफेस रहता, बल्ब फोकस के पास बल्ब रहता, बल्ब का लाइट रेस कॉन्केव मिरर के ऊपर रिफ्लेक्टिंग सरफेस के ऊपर गिरने के बाद आपको एक स्ट्रॉन्ग पैरेलल बीम मिलेगा. सो ये स्ट्रॉन्ग पैरेलल बीम बहुत दूर तक फोकस करेगा लाइट को, जिससे आप नाइट में ऑब्जेक्ट्स को देख सकते हैं. और ये पोजीशन आप टॉर्च लाइट्स में, सर्च लाइट्स में, व्हीकल्स का हेडलैम्प्स में देख सकते हैं. तो you will get parallel beam of rays. देख सकते हैं ना parallel beam of rays कितना दूर तक आ रहे हैं, strong parallel beam of rays. So ये position second position है. Is that okay?
Yes, sir.
Now third point, object between F and C, center of curvature and focus. Let's quickly draw this ray diagram. I have taken one concave mirror. Focus, center of curvature. Object is between focus and center of curvature. What happens? A parallel ray will pass through focus. A ray passing through center of curvature will be moving back in the same path. Both the rays are intersecting at one particular point and image is formed at that point. I'm extending the principal axis. So real inverted enlarged image, you got a real inverted and enlarged image. If AB is the object, A dash, B dash will be the image. Inverted, real images are always denoted by solid line. Real images, solid line. Real images are always below the axis. Virtual images, dotted lines, and they are always formed above the axis. Virtual images कभी भी above the axis रहते, real images कभी भी below the axis रहते. Real images को आप solid line से denote करते. यहाँ पर nature क्या है? Real and inverted. Size क्या है? Enlarged और magnified. Position क्या है? Position है beyond C. Beyond C. Okay, real inverted, enlarged image beyond C. Is that okay?
Yes, sir.
Yes. Object at center of curvature C. Let's draw a concave mirror. Principal axis, pole, focus, center of curvature. Let's keep the object at center of curvature. AB is the object. First rule says that any ray parallel to the principal axis passes through the focus after reflection. Almost in every position, every case, we are using the first rule. A ray parallel to the principal axis will pass through the focus after reflection. Now here you can't use this second rule, which is a ray passing through the center of curvature will move back in the same direction. Generally, we use this in previous cases, but in this case, we can't use this rule. Why? Because the object is itself at C. If object is in front of C, you can say that the ray passing through the center of curvature will move back in the same direction. You can draw one ray. You can use that rule. But now object is at C. Object C के पास है तो आप second rule use नहीं कर सकते. रे C से पास ही नहीं हो सकता. तो दूसरा रूल यूज करेंगे, थर्ड रूल यूज करेंगे. थर्ड रूल कह रहा है कि if the ray is passing through the focus, if the ray is passing through the focus, after reflection, it will become parallel to the principal axis. After reflection, it will become parallel to the principal axis. So this is the image formed. जहां पर दोनों रेस कट हो रहे ना बेटा, वहां पर आपको इमेज फॉर्म होता है, रियल इन्वर्टेड इमेज, सेम साइज इमेज मिलता है आपको. ऑब्जेक्ट साइज इज इक्वल टू इमेज साइज. रियल इन्वर्टेड पोजीशन एट सी. Very important ray diagram. So what is the nature? Real and inverted. What is the size? Same size. And lastly, what is the position? At C. So when object is kept at C, you will get image at C. Got it? Can you tell what is the magnification at this moment, at this point? ध्यान से देखिए. If you want to know the magnification at this point, you can find the magnification. The magnification is nothing but height of the image by height of the object. Both are having same size. That means object size is equal to image size. That means both the numerator and denominators are equal. Let it be x. But one is above the axis and the other one is below the axis. So image is below the axis, so image height will be negative. Object is above the axis, object height will be positive. Both the sizes are equal, so you will get -1 as the magnification. Even if you take any other formula, which is -v by u, where v is object distance, sorry, image distance, v is image distance, u is object distance. Even if you use this formula, both are at the same place. That means they are equidistant from the pole. That means object distance is equal to image distance. But both are negative. Why? Because we are measuring the distance in the opposite direction of the incident ray. आप इंसिडेंट रे के ऑपोजिट डायरेक्शन में डिस्टेंसेस मेजर कर रहे हैं, तो दोनों भी नेगेटिव रहेंगे. तो आपको ऑब्जेक्ट डिस्टेंस भी नेगेटिव आएगा, इमेज डिस्टेंस भी नेगेटिव आएगा, क्योंकि आप उल्टा डायरेक्शन में मेजर कर रहे हैं. तो इस बार भी आपको मैग्निफिकेशन एक्स एक्स कैंसिल होके माइनस माइनस कैंसिल होके -1 आएगा. तो मैग्निफिकेशन when the object is at C is -1. Object is placed beyond C. So let us draw a concave mirror. Let's draw principal axis. Let's mark pole and center of curvature. Object is placed beyond C. So you can keep the object anywhere beyond C. I'm keeping the object over here. AB is the object. Parallel ray ray parallel to principal axis. After reflection, it will pass through the focus. Okay. Next, a ray passing through the center of curvature. A ray passing through the center of curvature will reflect back in same direction. This is the point where both the rays are joining. You will be getting diminished image between C and F. So what is the nature of the image? Real and inverted. What is the size of the image? Diminished. What is the position of the image? Between C and F. If if AB is the object, A dash, B dash is the image. Got it?
Yes.
Please write down. The last position, object at infinity. Let's draw one concave mirror. Reflecting surface, principal axis, pole, focus, center of curvature. Object is at infinity, so the rays from infinity are falling on the concave surface of the concave mirror. Parallel rays are coming from infinity and falling on the concave mirror. After reflection, what happens? They will meet at, can you tell where they meet?
Focus.
They will meet at focus. So what will be the position of the image?
Sorry,
Position of the image will be
and the mirror.
image will be forming at focus. Understood? They will be meeting at focus, not exactly at focus, just below the focus. So you will get point size image at focus, highly diminished image at focus. This is the image. So now tell what is the size of the image?
Diminished.
Highly diminished. You can even tell it as point size image. And what is the position? Position of image is at focus, and nature of image will be, you can tell, real and inverted. You can write real and inverted. Okay. These are the ray diagrams related to concave mirror. Now I'm going to teach you how to draw ray diagrams of concave mirror. So we are going to discuss image formed by concave mirror. Okay. Before starting the ray diagrams, I want to tell few important things. If this is a concave mirror, this is pole, focus, center of curvature, axis. Now, one thing always remember, object is always kept in front of the mirror. ऑब्जेक्ट को कभी भी मिरर के सामने रखे तो ही इमेज आता, मिरर के पीछे ऑब्जेक्ट रखने से कोई इमेज नहीं आता. ऑब्जेक्ट इज ऑलवेज प्लेस्ड in front of the mirror. Object is always placed above the principal axis. Object above the principal axis रहता. Okay. Object erect रहता. Inverted object नहीं रहता. Object कभी भी straight रहता, erect रहता. समझ में आ रहा आपको? Object in front of the mirror रहता, object above the principal axis रहता. Okay. So what all positions you can place? Object को कहाँ कहाँ place कर सकते? Between F and C. आप ऑब्जेक्ट को between F and C रख सकते. ऑब्जेक्ट को फोकस एट फोकस रख सकते. ऑब्जेक्ट को between C and F रख सकते. ऑब्जेक्ट को एट C रख सकते, सेंटर ऑफ कर्वेचर. ऑब्जेक्ट बियॉन्ड C रख सकते. ऑब्जेक्ट एट इंफिनिटी रख सकते. कितने केसेस हो गए? 1, 2, 3, 4, 5, 6 cases. Once again, will you keep the object before the mirror or behind the mirror?
Before the
In front of the mirror. Always remember, object is kept always above the principal axis. So the first position is between F and P, pole and focus. This is called object kept very near. इसको क्या बोलते हैं? Object is kept near to the mirror. First case क्या है? Object is kept between focus and pole. Next case, object is kept at focus. Next case, object is kept between center of curvature and focus. Next, object is kept at center of curvature. Next, object is kept beyond center of curvature. Next, object is kept at infinity. Rays are coming from infinity. These are the 6 cases, 6 types of images formed. 6 types of images formed. 6 ray diagrams. Okay. Now, few things you have to remember. Image can be Virtual erect. Virtual erect image forms above the principal axis. Virtual images are denoted by dotted lines. Virtual images are denoted by dotted lines. This type of image is called virtual erect. Got it? Now,
Yes.
real and inverted images are formed below the axis. These type of images are called real and inverted. Real images are denoted by solid line. Inverted images are always lying below the principal axis. So what is the difference between virtual erect image and real and inverted image? Virtual erect images are formed above the principal axis. Real inverted images are formed below the principal axis. Virtual erect images are formed behind the mirror. Real inverted images are formed in front of the mirror. Real images are inverted always and they are denoted by solid line. Virtual and erect images are above the axis, behind the mirror, and they are denoted by virtual images are denoted by dotted line. Understood?
Yes, sir.
Now,
Yes.
first position, where is the object kept? Case 1. Object
Between
is placed between pole and focus. Object is placed between what? Pole and focus. First of all, draw a neat concave mirror. Draw the reflecting surface. Identify pole. Principal axis. And this point is focus. This point is center of curvature. Make sure that these distances are equal. These distances must be equal or else your figure diagram goes wrong. Now, where is the object kept? Object is between what points? Pole and focus. So object is here. I already told object is placed above the principal axis. Got it? Now, a parallel ray parallel to principal axis passes through focus. We already know the rule. A ray parallel to principal axis passes through focus. Next,
Kalena.
a ray passing through the center of curvature will reflect back in the same path. जो रे सेंटर ऑफ कर्वेचर से पास हो रहा वो वापस वही रास्ता में वापस आ जाएगा। 2 एरोस मैं यहां पर ड्रॉ कर रहा हूं, आप देख सकते हैं इंसिडेंट रे का एरो, इंसिडेंट रे का एरो, रिफ्लेक्टेड रे का एरो। यहां पर आप रेड कलर का इंसिडेंट रे का एरो और रिफ्लेक्टेड रे का एरोस देख सकते हैं आप। These two rays are diverging rays. These two rays can't meet here. ये पार्ट में ये रेस मीट नहीं कर सकते क्योंकि ये डाइवर्जिंग रेस है, इस तरफ मीट नहीं होंगे इन लोग मीट हुआ तो behind the mirror when you extend these rays back, when you extend these rays in backward direction, they will meet at one point. And when these two rays, wherever these two rays are meeting, their image is formed. And the image formed is virtual erect image. Virtual erect images are shown by dotted lines. This is the image formed. Image is formed behind the mirror and the image is virtual erect. If AB is the object, A dash, B dash is the image of the object. Which two rules are used here? Parallel ray passes through, parallel ray passes through the focus. First rule, a ray passing through the center of curvature will move back in the same path. Second rule, these two rules are used. Here there is no possibility of forming an image in this here in this part. Why? Because the rays can't meet. Why? Because they are diverging rays. ये दूर बिछड़ जाने वाले रेस है, जितना ड्रॉ करेंगे उतना दूर जाएंगे। तो जहां पर दो रेस मिलेंगे ना वहीं पर इमेज आएगा, तो इमेज यहां फॉर्म नहीं कर सकता क्योंकि रेस मिल रहे नहीं यहां पर। तो रेस कहाँ मिल रहे हैं? Rays are joining, they are meeting behind the mirror. When you draw these rays backward direction, they are meeting behind the mirror, and this is the image of the object. What is nature of image? Can you tell about nature of image? Image is virtual
Correct.
and erect. The image is what? Virtual and erect. Got it? Can you tell the position of image? Behind the mirror. Can you tell about size of the image? Enlarged or magnified. So I am calling it as enlarged image. Why? Because object size is small, whereas image size is big. Whenever image is bigger than the object, we call it as enlarged or magnified image. Understood? So at the end of the ray diagram, you need to tell about nature of the image, position of the image, and size of the image. Now this position, that means object is kept very near to the mirror. Object is kept between focus and pole, and it is very near to the mirror. This position is used in our daily life in case of shaving mirror. So concave mirror is used as shaving mirror. Why? When you keep the mirror very near to your face, you can see small hair. Shaving mirror or makeup mirror, they are kept very near to the face to see small hair. Got it? Understood?
Yes, sir.
So this is concave mirror is used as shaving mirror. When the concave mirror is kept very near to the face, that means object is kept near to the mirror. Okay, you can see even small hair of your beard. It will be easy to see them and shave them. Got it? Concave mirror is also used as makeup mirror. Your face is the object. Face is kept very near to the mirror. Your object is kept very near to the mirror. You can see the face clearly and it magnifies things. It will magnify. The face will look little bigger. The concave mirror magnifies it, magnifies the hair of the face. It will magnify the face so that you can clearly see and do the makeup. If you are makeuping the eyeliner or applying some face cream or shaving beard, then you have to keep the concave mirror very near to your face so that the image will be bigger. You can clearly see small things. This position is used in case of shaving mirror and makeup mirror. Moreover, if you have visited a dentist will use this position. So dentist will use concave mirror. He will use a concave mirror, long handle concave mirror. Okay, he will keep the concave mirror very near to your tooth. This is the cavity. Imagine that this is the cavity inside the tooth. He will keep the mirror very near to the object, that is tooth, and he will get enlarged image. Small cavity will appear bigger in size. We are getting enlarged image when object is kept very near to the mirror now. So that small cavity, it's very uncomfortable to see that cavity through the mouth. Patient has to open the mouth and the tooth may be at the corner of the mouth, and still he can see with the help of concave mirror. With the long handle, he can easily place the concave mirror near the tooth and he can see the image behind the mirror, enlarged image he can see behind the mirror, and he can do operation on the tooth. He can do the necessary needed things on the tooth. He can do root canal. Okay, he can even he can even drill the tooth and fill it with cement. He can treat the tooth cavity, and concave mirror is used by dentist, and this position is used by dentist Object is kept very near to the mirror. Enlarged image is produced. And I already told you two uses of concave mirror. Dentist uses concave mirror to see the cavities in the tooth, and concave mirror is also used as shaving mirror and makeup mirror. First ray diagram is drawn and applications also explained.